Since we're looking at trigonometric functions as functions, one of the key concepts that we discussed first when introducing ourselves to functions was the concept of the domain and the range of a function. So let's look at how the domain and the range correspond to our 6 trigonometric functions. But first we will look at the concept of the unit circle, which is not a method that I will typically rely upon, but it is useful in this particular concept. So the unit circle is simply the circle that has a center of 0, 0, the origin, and has a radius of 1 unit. So let's let AB be a point on the terminal side. Then the distance R to that point is 1 unit. So now as we look at evaluating our trigonometric functions for theta, we know sine of theta is b over r, but that's just b. Cosine of theta is a over r. Tangent of theta is b over a, and so on and so forth down the rest of our 6 trigonometric functions. So what we can do here is we can actually think of this ordered pair for this point being nothing more than cosine of theta, comma, sine of theta. Now let's look at the sine function. So as we look at the sine function, and we look at the point A, comma, B for an angle theta, if we're looking at the domain of our sine function, the question is, are there going to be any problematic values for theta? So as theta wraps around the origin, as we go around either clockwise or counterclockwise, are there going to be any problems for B? Are there going to be any places where B is not going to be defined? And as you look at the output, there are going to be no ordered pairs for which B will not be defined as we traverse the circle. So therefore, there is no unallowed value for theta. So the domain of the sine function is all real numbers. So the domain is simply negative infinity to infinity. Well, what about the range? So the range, if you think also now about the fact that B is the output of the sine function, so sine of theta equals B, B is the output. What are the values that B can take on? Well, B is restricted to being on the y, or being the y value of this circle. So where can B go? The lowest B can be is negative 1. This is the lowest y value of the circle. Here B is 0, and B is increasing to be 1 here. So B is always between negative 1 and 1 inclusive. So therefore, the range of the sine function is negative 1 to 1. Now as we move to the cosine function, it's going to be similar. We have a comma b for that point on our terminal side, and so there's our angle theta, and like before in our sine function, the domain will consist of any real number. There is no unallowable value for our angle. And now the question is what can cosine of theta output? But cosine of theta is a. So what are the values that a can take on? So a is the horizontal coordinate of this point. So you'll notice that the largest horizontal coordinate that A can be is 1. If we traverse the circle, here our horizontal coordinate is 0, and here our horizontal coordinate is -1. So that means the range of our cosine function is again -1 to 1 inclusive. Let's look now at the tangent of theta as a function and determine its domain and range. This is a little bit more complicated, but as we look at the tangent of theta, to figure out what theta is not allowed to be, let's look at the output and see any problem values that would arise. And our output would be problematic if A would be 0. So what would yield A to be 0 for theta? So if theta is pi over 2, then A would be 0. Likewise, 3 pi over 2. And back and forth. This relates to the period of our tangent function. Every pi units we have an issue with the tangent function. So if theta is pi over 2, we have a problem. If we then go to another pi units from there, we have a problem. And on we go. So we do not want tangent of theta to be undefined, so theta cannot be pi over 2 or any additional period away from pi over 2. So therefore, the domain, we won't use interval notation for this, the domain is the set of all theta where theta is a real number and theta does not equal pi over 2 plus pi k for integer k. So now let's look at the range. So what are the possible outputs? This is not as obvious, but A could be getting to be closer to 0 but positive, which means that as A gets closer to 0 but positive, B is getting closer to 1. So we have a number that is close to 1 over a smaller and smaller and smaller value of A. Now what's happening to that fraction then? If that's the case and we have a positive number over a positive number, but the denominator is getting smaller and closer to 0, and the numerator is getting close to 1, then that is something like 0.9 over something that's close to 0. That's going to be a large number. And likewise, we could be down here, and A could be getting closer and closer to 0, and B could be negative, in which case we're close to negative infinity. So therefore, we can assume all values between negative infinity and infinity for the range. So let's remember that cosecant of theta is r over b, but this is the unit circle, so r equals 1. So if cosecant of theta is 1 over b, what are the problematic values that we could face? If b equals 0, then this output would not be defined. So when is b equal to 0? Well, b is the y-coordinate of this point. So when y equals 0, our angle would be 0, or pi, or 2 pi, or 3 pi, or we could go clockwise and we would have negative pi, negative 2 pi, so on and so forth. So if we don't want b to equal 0, then theta cannot be 0 plus any multiple of pi. So that means that theta should not be pi k, where k is an integer. So the domain will be all theta, where theta is a real number, and theta is not equal to pi k for integer k. What's the range then? Well, there are two possibilities. Since b isn't 0, then b could be positive. And if b is positive, that means that the y-coordinate is above the x-axis, so we are on this portion of the circle. If b is positive, notice that b also has to be under or equal to 1. Since b is less than or equal to 1, then this means that 1 over b would be bigger than or equal to 1. Well, what about if b is negative? If b is negative, then we're on the under portion of this circle, and if b is negative, then b would have to be bigger than or equal to negative 1. And if that's the case, 1 over b would be less than or equal to negative 1. Let's put this together. We have two possibilities. Either 1 over b is bigger than or equal to 1, or 1 over b is less than or equal to negative 1. But 1 over b is cosecant of theta. So cosecant of theta is either negative infinity to negative 1, or is on 1 to infinity. So this piece is this, and this piece is this portion. The output has to be in one of those intervals. So this is the range. Now let's look at secant of theta. For the secant of theta, we'll want to remember that secant of theta is r over a. But again, r is 1 in the unit circle. So we have secant of theta is 1 over a. Now again, we have the problem for this if a is equal to 0. So that would be true. If a equals 0, we're dealing with likewise, secant of theta is 1 over a. Now, with secant of theta being 1 over a, we know that a can't be 0, and the only time that a is 0 is if we land on the vertical axis. So that would be if theta is pi over 2 or 3 pi over 2, or any angle that is coterminal with those. So theta cannot be pi over 2 plus any pi unit multiple away from that. So the domain would consist of all theta where theta is a real number and theta does not equal pi over 2 plus pi k for integer k. What's the range? Well, without going into the same level of detail as we did in the previous slide, the range is negative infinity to negative 1 union 1 to infinity. So let's look at cotangent of theta. And cotangent of theta will be a over b. So what's the domain? The domain would have to exclude any values where b is equal to 0. But b equals 0 would mean that we're dealing with a y-coordinate that is 0, so that will be here or here. So that will be at 0 or pi or any angle that has a coterminal side as 0 or pi. Therefore, we're dealing with, for the domain, the admissible values, the allowable values of theta are all theta, where theta is a real number, and theta does not equal 0 plus pi k. So pi k, where k is an integer. Now, just like the tangent function, cotangent of theta has a range of all real numbers.